In this video, I'm going to be showing a few options for shortwave transmitters. So shortwave transmitters are pretty rare if you are not looking at ham radio transmitters, but you want an actual shortwave transmitter. It's pretty hard to find them, and there's only a few people that make good ones. So there's two people that I know of. Number one is Stretchy Man, and another one is this guy. His name is SVIPOLYC, I think. It's something on eBay. If you search up AMPWM, you'll come up with something that looks like this on eBay. And so that's one option. He also sells this, which is a Dds Modulator. So this right here is a 100 watt carrier, 400 watt PEP shortwave transmitter that operates between the ranges of 3 and 8 megahertz. It has a little L right here to control the frequency with a rotary encoder, and then this pot right here controls the power output. So it's a PWM. So that basically means that it's around 90% efficient because these MOSFETs are being driven at 100% power, I guess. So basically it operates at their maximum efficiency range because they're running it up to the full power by using PWM. So this is the PWM driver. It leads through here into the PWM filter, and then that goes into the amp and powers that. Interesting thing about PWM transmitters is they use a different kind of transistor compared to normal HF linear amplifiers. So they use these types of transistors which are almost like audio amplifier transistors. This one's an IRFP 260, I think. IRFP 260N. These have been scraped off, I guess, because he's trying to protect his design. But it uses either switching power supply transistors or audio amplifier transistors because they work up to around 8 megahertz in the RF range. So they can be used for RF, just not VHF. So that's the PWM right there. Now this is what I want to get into more, because this is a very simple, cheap shortwave transmitter setup compared to something like this, which is much more expensive, but it's also more efficient. Over here, what I have is it's a DDS modulator. It's an AM transmitter that outputs 1 milliwatt of power, and it will output that power between 100 kilohertz and 30 megahertz. So what happens is you've got just a normal 12 volt power supply pin header right there. Then right next to that you have an audio input pin header. You have the power adjustment pot right there and the screen contrast. And then over here was another pin header, but what I did, because I wanted a better connector on it, I bought a little SMA connector and I chopped off 2 of the mounting things that are part of it, and I just soldered it onto this pin header. So now I have a good way to connect an SMA connector to the output here, because it's kind of annoying to just use wires on these things. It doesn't work very well. So it's a SMA connector, and then you just have an SMA cable, if I can find one like this, an SMA cable that connects from here to the input, and then you get another SMA connector that goes into, you probably use an SMA cable that has an SMA on one end and then a BNC or N connector or whatever type of connector you're using for your antenna. You have that so it converts this to the antenna connector. But anyway, this is an amplifier from the Ukraine, and it's actually pretty good because it takes 1 milliwatt of input and it amps it up to 20 watts carrier, or roughly 5 watts AM, and then it gets peaked up to 20. So this thing produces 20 watts of power. It has a 24 volt input right up here, and then because this thing runs on 12 volts, I have this cable to power this thing right here, and I have that wired up to a 12 volt voltage regulator that I installed right here. So I have it, the power coming to 24 volts coming in here, and then just converted to 12, so I don't have to have a separate power supply for this. And then the power supply that I use for this is a Meanwell LRS 7524. It's a 75 watt 24 volt power supply, which is plenty of power for this setup. It's really small and light too. It's good. So that's the basic setup, and then you would get something like a bird meter, like an SWR meter, and hook this up to the antenna with a really low power. Test it out if you don't have an antenna analyzer, but it's better to have an antenna analyzer. This is a really good one, but you could just use something simpler that MFJ makes. This is called the Rig Expert AA600, and let me just turn it on briefly. And so you hook that up to your antenna, and then to find out what the resonant point of the antenna is, you press, well, you first set the frequency to what you want it to be, or what you think it's going to be near. You type that in there, and then you go to number 3 and you set the range that you want it to scan across. And then you go to number 4, and right now I have nothing connected to it. So you can see the line goes all the way straight across like that. But if I do something like, okay, so I just plugged the antenna into the end of it there, and now if I scan it again, hopefully we can see something here. Yeah, see? Right there. So now you know exactly what frequency your antenna is set to. Right there. 6762 currently. And raising and lowering the middle point of the antenna changes the frequency drastically compared to cutting the ends. So if you cut the ends of the antenna and you get it close enough to the frequency that you want, but it's not exactly on it, try raising and lowering the center point of the antenna first to see how much you can change it without cutting any more off, because that makes it a lot easier to tune if you ever want to change your frequency. Instead of cutting it, because that's permanent, you can just change the height of the center and it will change the frequency. So that's pretty much it. Something else about this amplifier is that over here it has a PTT, which is a push to talk. So that's used for ham radio when you want to have the amplifier only operate while you're talking. But if you're using it constantly, then you just short this out right here. You create a little connection between that, or you can connect onto that pad above it. You can connect 12 volts there, and it should accomplish the same thing. I did have a problem with this though, that when I connected this resistor right here started to overheat. I don't know why it is, and I contacted the seller of this and he said he's never had that problem before. So it was strange that this was getting so hot, so I removed it and it works fine without that resistor there at all. And everything else is fine. I've ran it for a while, nothing else gets too hot, and it works just fine. So if you have a problem when you connect this, that this thing starts to overheat, then just remove it and it'll work fine. It does disable the push to talk though, so if you're going to use it for ham, then it's not going to work anymore, but it works fine for constant usage. Another thing about this amplifier is down here, it has an optional place where you can solder your own low-pass filter on. So you don't necessarily have to go and buy a separate low-pass filter like that one, for example. You can, because then it's easier to just switch them in and out. Like if you want to change bands, you can put a new one of these on there and then just use a different frequency. Or you can even get modules of low-pass filters that have a bunch of different low-pass filters all on one board, and they have little relays that switch between the different bands, so you don't have to change the filter out each time you change the band. But that's not really always necessary for a simple setup where you always want to use the same band. So if you want to use the same band, you can just create your own low-pass filter right here. This may be, though, given that this is HF frequencies, the spacings for these coils are pretty small, so I really don't know how much you're going to be able to fit in here. You might not be able to do like an 80 or a 40 filter, but you might be able to do a 20 maybe, just because there's not so much space in there. Even if you get toroids like that and wrap it around, there's still not that much. You can see my finger right there. It's not that much space. So you can try it, and it would be a lot better to have the filter on the board itself rather than having a separate thing. But it may not fit. So what you would do, though, is you would just put the toroids there wrapped in the proper number of turns of wire that you can find online, you can calculate. And then you solder those there, and then you have the 4 capacitors that you put down here. And then these resistors get removed because right now they are 0 ohm resistors, so they're just connecting. They're just connectors that connect this together so that it works without a filter. But if you want to use the filter, you remove those and put the toroids on there and the capacitors on there. So yeah, that was just something else I wanted to add on about this amplifier.